Good evening, all of you. Yesterday I had given the different formula that will come across in measures of central tendency. Now, this is nothing but the continuation for that. And today I'm going for measures of dispersion. Okay, dispersion means nothing but differences that will come across between the variable values as well as the central value or the representative value. So today I'm going to take up that opportunity to explain you about the different formula that will come across in the measures of dispersion. And before going to measures of dispersion, people, they must be very thorough with this various formulas that we come across in the measures of dispersion. Yesterday itself also, I told you that we have to be very cautious and very careful in writing and in remembering the formula, various formulas. Okay, and you have to practice. One thing you have to do is regular practice is very, very important when we go for business statistics 1. And today I'm going to take into account the measures of dispersion or differences. And this difference you'll come across between the central values, as that is averages, as well as the variable values or each items of the series. And one thing you have to remember that, as I told you already, that we'll come across the 3 types of series or the 3 types of observations, both in measures of central tendency as well as in measures of dispersion. That is individual observations, discrete observations, and continuous observations. In simple, people, they'll call that thing as individual series, discrete series, and continuous series. Whatever it may be, the name that you assign, okay, they are one the same. Now, when we go for measures of dispersion, we'll have 5 methods. We'll have 5 methods, and the last method is a graphical representation. So we have to concentrate on the 4 important things that we'll come across. And what are the 4 important things that we'll come across? First one is range. Second one is quartile deviation or semi-interquartile range, semi-inter-range. Okay, and third one is mean deviation. And the last one and the most important one is standard deviation. These are the important 4 methods that we come across. And what is the 5th one, sir? The 5th one is nothing but Lorentz curve. And this is completely a graphical method that we come across. And among the five methods of measures of dispersion, 4 methods are very, very important. Okay, and in these 4 methods also, 2 are just we can able to understand, and 2 are we have to understand carefully and cautiously. So please be attentive for the formulas, what I am going to give, what I am giving. Okay, and you please take down the formulas, whether you are going to by heart that or whether you are going to understand that, it's up to you. But thing is, practice compulsory, you have to do. As there is a proverb that practice makes man perfect. In the same way, you have to practice. Okay, and I'm not telling that to practice these measures of dispersion. You have to practice measures of central tendency, and after that, you have to practice this measures of dispersion. Okay, so let us go for this measures of dispersion. When you are going for measures of dispersion, one thing you have to understand is we'll come across absolute measure and relative measure. So what is this absolute measure and what is this relative measure? Absolute measure is that measure in what units of measurement we have taken. In that units of measurement only, we will come across the value. So that is nothing but absolute measure. Relative measure. Relative measure is also known as coefficient. We'll also call that thing as coefficient. And this relative measure, it does not belong to any units of measurement. It does not belong to any unit of measurement. It is an independent value that we will come across. And when you are going for measures of dispersion, compulsory, you have to find out the absolute measure as well as relative measure. Keep that in mind. And whatever it may be the series, whether you take individual series, discrete series, or continuous series, compulsory you have to find out the absolute measure as well as relative measure. So 1 to 10 times I'm telling the same thing. So I suppose that you have to understand, you must understand this and be cautious and careful in understanding the formulae and keep that in your practice. Okay. Now, one by one, I'm going. Range. It is the difference between the largest item and the smallest item. It is the difference between the largest item and the smallest item of the data. Okay. So symbolically, it is represented by L minus S. L stands for largest item and S stands for smallest item. This is nothing but an absolute measure. This is nothing but an absolute measure. So whether we'll come across relative measure, yes, we will come across, okay, and that relative measure, we'll call that thing as coefficient of range, coefficient of range. So what is the formula for calculating this coefficient of range? The formula for calculating coefficient of range is equal to L minus S by L plus S. That is difference between the largest item and smallest item by summation of largest item and smallest item. This is the coefficient of range formula. So all the people, they must be very thorough with this. Okay. Relative measure as well as the absolute measure. And so suppose when we are given continuous series, okay, what we have to do? There, you have to take into account the lower limit of the first class and the upper limit of the last class. Okay, the lower limit of the first class as well as upper limit of the last class. And you have to take the difference. Okay, that will give you the absolute measure. And when you take into account the difference divided by summation will give you the coefficient value. Okay, so whatever it may be, whether it may be an individual series or discrete series or continuous series, you have to calculate the range in that manner. Okay, now after range, we will come across quartile deviation or semi-interquartile range. Semi-inter-range. Okay. So what is this? So when you are going for quartile deviation, compulsory you have to take into account the quartiles. That is the first quartile as well as the third quartile. That is 25% of the data as well as 75% of the data you have to take into account, and you have to take into account the difference between the third quartile as well as first quartile. So the absolute measure of quartile deviation QD is equal to, quartile deviation will represent that as QD, Q dot D. Okay, quartile deviation is equal to Q3 minus Q1 by 2. This is the formula for absolute measure. And what is the relative measure formula? Q3 minus Q1 by Q3 plus Q1. This is the coefficient or relative measure for calculating the quartile deviation. So you must be very thorough in finding out the quartiles. Okay, first quartile as well as third quartile. Yesterday itself, I told you that these quartiles are nothing but the other related positional averages after seeing the median. And what is this quartiles? When you take the data and when you divide the data into 4 equal parts, leaving one part and considering the other 3 parts is nothing but quartiles. And the second quartile is always equivalent to the median value. So you have to take into account the first quartile as well as the third quartile. That is 25% of the data as well as 75% of the data you have to take, and you have to see the difference between these two percentages. Okay, and yesterday itself I told you that the formula to calculate the first quartile as well as third quartile in individual series, discrete series, as well as in continuous series. When you go for continuous series, mind that you will come across the first quartile class as well as the third quartile class. And after getting these classes, you have to use the interpolation formula. And after applying the interpolation formula, then only you are going to get the first quartile class or first quartile value or the third quartile value. Then after that only you have to take into account Q3 minus Q1 by 2. Okay, this is nothing but the absolute value. And when you take into account Q3 minus Q1 by Q3 plus Q1, you will come across the coefficient of quartile deviation. Okay, and one more thing here, I'm just refreshing, that is interpolation formula. Interpolation formula, okay, when we go for first quartile, okay, Q1 is equal to L plus n by 4, because continuous series, we will come across classes, mind it, n by 4 minus CF by F into I. This is the interpolation formula to calculate the Q1 value, and the interpolation formula for Q3 value is equal to, okay, Q3 is equal to L plus 3n by 4 minus CF by F into I. This is the third quartile value. So after getting this first quartile and third quartile, okay, then you have to take into account the difference, and that difference, if you divide that with 2, you are going to get the absolute value. And after that, we are going for coefficient of quartile deviation. Already I told you that it is nothing but Q3 minus Q1 by Q3 plus Q1. Okay, fine. Now, after quartile deviation, we have to go for mean deviation. Here, what we will do is, we'll take into account the arithmetic mean or median, because we should not take into account the mode. You can use, but thing is, okay, regularly people, they are taking into account the arithmetic mean as well as median. Okay, and from this arithmetic mean or median, they are going to take into account the deviations. And here the peculiar thing is, you have to ignore the signs. When you are going to ignore the signs, we have to represent that deviations as mod D, or in other words, we'll call that thing is D within parallel lines. So mod D or D within parallel lines. So when you are going for mod D, it means that whether you come across positive signs or negative signs, we have to forget that, we have to ignore that. So like this, you will come across the deviations for this. Okay, and what is the formula to calculate mean deviation when we go for arithmetic mean? That is, when we go for individual series and discrete series. Okay, the formulas to calculate is, one second. So the mean deviation formula in individual observations is equal to, okay, mean deviation or MD. We'll represent this mean deviation as MD. Mean deviation or MD is equal to sigma mod D by N, where D is equal to deviations taken from arithmetic mean or median, ignoring signs. Some people, they will tell, they will take arithmetic mean, and some people they will take median. Okay, you can use any of them, arithmetic mean or median. Okay, fine. N is equal to total number of observations or total number of items that we come across. And what is this coefficient of mean deviation in individual series? Okay, coefficient of mean deviation is equal to mean deviation by arithmetic mean or median. You can use arithmetic mean or median, anything. So with that average, if you divide the mean deviation, you are going to get the coefficient measure or relative measure. So this is how you will come across, okay, calculation of mean deviation under individual series. Now coming to discrete series, here in discrete series you'll come across frequency along with the variable values. So mean deviation is equal to sigma f mod D by sigma f or n. Sigma f mod D by sigma f or n. So here what you have to do is you have to take into account the arithmetic mean, and you have to go for median. And from this arithmetic mean or median, you have to take the deviations of the variable values. And whatever it may be, the deviations, whether you get positive values or negative values, you have to consider that as positive values. Okay, that will become mod D. And this mod D, it should be multiplied by the corresponding frequencies. So f mod D, after totaling this, okay, f mod D, okay, you'll get sigma f mod D, sigma f mod D, and you have to calculate the frequencies, and that will become the sigma f or n. So the formula is mean deviation is equal to sigma f mod D by sigma f mod D by n or sigma f. This is the formula to calculate the mean deviation value, that is absolute measure. Now, when you are going to take into account the relative measure, relative measure you can calculate easily. That is mean deviation by, that is coefficient of mean deviation by arithmetic mean or median. Okay, you have to divide the mean deviation with any of the two averages, arithmetic mean or median. So you may ask me, sir, why we should not take into account the mode, geometric mean and harmonic mean? So when you take into account the mode, geometric mean or harmonic mean, whatever it may be, the deviations that you come across, they will be large. And when you take into account the arithmetic mean and median, okay, here also the deviations that you take from median, they will be minimum than arithmetic mean. Okay, so generally people, they'll follow this arithmetic mean or median. Okay, so this is why we have to take into account this arithmetic mean or median. Now coming to continuous series, what is this? Okay, so the formula is mean deviation is equal to same as sigma f mod D by n. Okay, in continuous series, one thing you have to keep in mind is you will come across the classes. Here, how to take the deviations? So first of all, you have to calculate the mid values. Okay, you have to take the mid values, and from the mid values, either you have to go for arithmetic mean or median. When you are going for median, compulsory you have to calculate cumulative frequency, and you have to take into account the formula size of n by 2th item and you have to locate where it is lying. All these things you have to take, and you'll get median value by applying this interpolation formula. And after getting the median value, you have to take deviations to the variable values. You have to take the deviations from variable values. That thing will become mod D. And that mod D you have to multiply with the corresponding frequencies. Thereby you are going to get F mod D. And after totaling this F mod D, you are going to get this sigma F mod D. And that sigma F mod D you have to divide with the total frequencies or n. So the formula is MD is equal to, that is mean deviation is equal to sigma F mod D by n, where deviations must be taken from mid values. Mind it. Okay. Now, there is a shortcut method also in this. When mean or arithmetic mean is in fractions, you have to apply this shortcut method. That is, mean deviation is equal to sigma MFA minus sigma MFN minus brackets begin sigma FA minus sigma FB into borax by n. And for median, it is sigma MFA minus sigma MFB minus brackets begin sigma FA minus sigma FB into median by n, where sigma MFA and sigma MFB stands for total of products of midpoints and frequencies corresponding to midpoints above and below the average value respectively. Sigma FA and sigma FB represents the total of frequencies pertaining to midpoints above and below the average value. N is equal to total number of observations. This is the shortcut method, and most commonly people they'll follow the first method, that is the direct method, instead of going for the shortcut method. Okay, now after this we are going for the important topic, that is nothing but standard deviation. So what is the standard deviation? Before going to standard deviation, you must know what is standard. Okay, we have to keep one thing as standard which won't change at all, which is fixed and which won't change at all. So when we go for this standard, automatically we can able to compare the actuals with the standard, and we can able to see why the actuals are not corresponding or not equal to the standard. Okay, for example, when you take into account the products, so many people, they'll go and they'll see whether there is ISI, Indian Standard Institution emblem, or is there or not. So when you come across this ISI mark, automatically people, they will understand this is a standard product, because it was recognized by the Indian Standards Institution, and that institution product, it is just genuine, it is perfect and genuine. So basing upon that emblem, some people, they will purchase that product. Okay, generally some products, they will have this Indian Standard Institute emblem. Some products they don't have. So it means that you will come across the malpractices and nakli, all these things you will come across. Okay, they are not good for health and other things. So they will follow this Indian standard. In the same way, what is the standard deviation, standard thing that we'll come across? Thereby we can able to compare, and then we can able to get the differences, perfectly without any fluctuations. So this standard deviation, it is explained by, as it is given by Carl Pearson in the year 1893, and This standard deviation is also known as root mean square deviation. Root mean square deviation. So why it is known as root mean square deviation? Because whatever it may be the deviations that we are going to take, we have to take from arithmetic mean only. And after getting the deviations, we have to see the square root. That's why standard deviation is also known as root mean square deviation. Okay. And here also you'll come across the absolute measure as well as relative measure. Okay. If you take into account individual series, discrete series, continuous series, whatever it may be, you will come across absolute measure as well as relative measure. Now, when we are going for this individual observations, individual series, what is the formula to calculate standard deviation? Standard deviation is denoted by a symbol sigma. Sigma. Okay, there is two names. There are two names with there are two things we will come across in standard in statistics with same name. Sigma, when you just take into account this thing, okay, this thing, okay, it represents the summation or total. And when you take into account the standard deviation, that is, you have to write like this. Okay, that shows the symbol for standard deviation. So sigma is equal to square root sigma small x squared by n. Here, everything should be squared. So why we have to square? Because whatever it may be the positive deviations and whatever it may be the negative deviations, they will be transformed into positive deviations, taking into account the okay mathematical properties of the signs. Okay, what are the mathematical properties of signs? Plus into plus is equal to plus, minus into minus is equal to plus, minus into plus is equal to minus, plus into minus is equal to minus. So taking into account the mathematical properties of the signs, what we have to do is we have to convert everything, and we can convert everything by by squaring that, by multiplying the same thing with the same thing. That is, for example, minus 2 into minus 2 is gives us plus 4. Minus into minus is equal to plus. So 2 into 2 is equal to 4. So you will come across the result as positive value, that is plus 4. In the same way, first of all, we have to take the deviations and we have to square that. And after squaring, you have to total that. So that thing will become sigma small x square. Sigma small x square represents the deviations that we are taking from arithmetic mean. In calculation of standard deviation, mind that, okay, mind that, keep in your mind that we have to calculate the arithmetic mean first. Compulsory arithmetic mean must be calculated first. And from that arithmetic mean only, you have to take into account the deviations, and they must be represented by small x. And that small x, we have to square that and we have to total that. Thereby you are going to get, okay, sigma small x square. And that sigma small x square we have to take, and we have to take the root after dividing that with the number of items in individual series. Okay, so the formula is equal to is sigma is equal to square root sigma small x square by n. Okay, where small x is equal to x minus arithmetic mean, that is bar x. Okay, this is one way to calculate this. And what is the other way, sir? The other way is when arithmetic mean is in fractions, that is in decimal points, it is difficult for us to take the deviations. So in that case, what we have to do is we have to use the assumed mean, that is A. Okay. And when we are using this assumed mean, automatically the formula will change. Okay, what is the formula, sir? Sigma is equal to square root d square by n minus sigma d square by n minus sigma d by n whole square. Mind it. Once again, I'm telling you. Okay, sigma is equal to square root sigma d square by n minus sigma d by n whole square, and the whole square will be both for sigma d as well as n. Okay, so this is the formula to calculate the standard deviation according to assumed mean method. Okay, whatever it may be, you are going to get the same answer. Don't be of that opinion that you'll come across different answers. You'll come across the same answer. In the first case, you are taking arithmetic mean and you are taking deviations. And in the second case, you are taking into account the assumed mean when arithmetic mean is in fractions. Okay, this is the thing that you have to keep in mind. Okay, now coming to discrete series. Here also, you will come across, okay, two methods. That is, first of all, we will take into account the arithmetic mean, and after that, we are going for assumed mean. Okay, fine. So what is the formula? Okay, when you go for arithmetic mean, sigma is equal to sigma, that is standard deviation, is equal to square root sigma fx square by n. Here, when you go for discrete series, compulsory you are going to get frequency place. So sigma fx square, small x square by n. N represents the total frequencies. This is the way to calculate the standard deviation. Sir, what about small x, sir? Small x is equal to x minus bar x, that is arithmetic mean. Okay, this is the formula to calculate the standard deviation when we go for discrete series. And you are taking arithmetic mean. Suppose when arithmetic mean is in fractions, then we have to take into account the assumed mean, and the formula will be transposed. It will be transposed. How? Standard deviation is equal to square root sigma fd square by n minus sigma fd by n whole square. Okay, like that of previous case. Here you are coming across frequency. Everything is one the same. Again, I'm repeating that standard deviation is equal to square root sigma fd square by n minus sigma fd by n whole square. This whole square will be for both for sigma fd as well as n. Okay, this is how you have to calculate standard deviation from assumed mean. Okay. Next, another thing is step deviation method. Step deviation method. What is this step deviation method? Here, when you take into account the deviations, sometimes when the values are very small, you'll get small deviations. But we won't come across the values every time small in number. Okay, so sometimes you may get large number of deviations or large deviations. When you want to reduce that, you have to divide that with a common factor, that is class interval or common factor. So thereby you come across the step deviation. So there the formula is standard deviation is equal to square root sigma fd dash square by n minus sigma fd dash by n whole square into I. Compulsory into I or C, whatever it may be, compulsory, because here we are minimizing that. And so when we are going for step deviation method, what thing that we have to use, that is whether we have to go for arithmetic mean or assumed mean. Okay, most commonly we have to use this assumed mean only. Okay, so d dash is equal to, I'm telling about that d dash is equal to x minus a by I. That is class interval or common factor between the values. This is how you will come across in discrete series. Now coming to continuous series. Coming to continuous series. Okay, you can apply any method. You can apply any method. Okay, but generally people, what they will do is they'll go for step deviation method. Standard deviation is equal to sigma fd dash square by n minus sigma fd dash by n whole square into I or C, anything. Okay, generally people, they'll follow this thing. Okay, so this is how you will calculate the absolute measures of standard deviation in all the observations, whether it may be individual series or discrete series or continuous series. And so what is the coefficient of standard deviation? Coefficient of standard deviation is equal to standard deviation by arithmetic mean into 100. We'll call that thing as coefficient of variation. The other name for coefficient of standard deviation, instead of talking standard deviation, we'll call that thing as coefficient of variation, because we are taking into account the variability. So coefficient of variation is equal to standard deviation by arithmetic mean into 100. So when you are multiplying with 100, you will come across this relative measure in percentage. So suppose if we won't multiply with 100, you'll come across, okay, the relative measure, that is coefficient of standard deviation is equal to standard deviation by arithmetic mean. It does not belong to anything. And when you multiply that with 100, you are going to get in percentage. Like this, you'll come across the calculation of coefficient of standard deviation or variation. And tomorrow I'm going to continue and we are going to complete by tomorrow. Okay. So until then, have a nice day. And after you, just if you follow this, okay, if it is easy for you, you please try to subscribe, okay, without any fail. I suppose that I'll be clear in this context. Okay, thank you. Good day for you.